Okay, Algebra 1, how you doing? All right, here's what I got. This is called 1.3 solving equations with variables on both sides. Okay, so instead of having just two-step equations where we have like a 3x plus 5 equals 10, and you have to get rid of that 5 and then get rid of the 3 in front of the x, you're actually going to have one more step involved, and that's when you have variables or maybe an x on each side of the equal to sign. Now, what are we going to do to get all your x's to one side and maybe all your non-x's, non-variables, to the other side? Okay, so let's practice that. There are only 5 slides in this PowerPoint, including the one that is our title page. So, all right, let me get this going. Boom. There we go. Okay, so I've got 2 problems here, and I don't know how many will show up on your sheet for example 1, but I've got 2 here. I'm going to start with the second one, if you don't mind, and I'm going to do the same thing that I did before. I'm going to cut the equal to sign right down the middle, and I'm going to ask myself, which side do I want to have the x's on? Do I want to have the x's on this side here, or do I want it on this side here? Okay, and the fact that this side over here only has one term that has an x with it, and here I have a couple different things, what I'm going to do is identify the variables on this side, which means I only want x's over here. I don't want x's on this side over here. Okay, so what I'm going to do is I'm going to get rid of that x because I don't want that here. I just want plain numbers over there. Okay, so all I want are numbers over here. Those are called constants. Not that you have to know that. I'm not going to touch on it, but constants are numbers that don't have a variable attached to it. Okay, so here's what I'm going to do. I got to get rid of this 3x. And to get rid of the 3x, I'm going to do the opposite of that. We're going to do the additive inverse in this case. And the inverse of a positive 3x is to subtract 3x. And whatever I do to one side, I have to do it to the other side. Okay. Now, that'll allow these to go away, and the 10 will come down. And on the left side, again, you can do this on your calculator, not that you can put x's in, but -2 minus 3. Okay, put that in your calculator, or just sometimes you can think to yourself, -2 plus a -3 gives you a -5. Okay, but there's an x with it. Okay, so that x goes with it. And now you have a problem like you had our first day of class. You have -5 times x equals 10. And how do we get rid of our -5? Well, the opposite of multiplication is division. And if I have a -5 here, I'm going to put the same thing there, -5, as a form of division. And we'll do it to both sides. And a positive divided by a negative is a negative. 10 divided by 5 is 2. I will box my answer. And we are done. If you want to check it, just plug it back into the original. Just take -2 equals 3 times something plus 10. And the item that you're going to plug in there is the answer. And see if you get a true statement. Okay, so again, I just rewrote the original problem, but wherever I had an x, I plugged in a -2. So -2 times -2 is 4. And 3 times -2 is -6 plus 10. You can do that on a calculator if you're not secure with that. And ask myself, is 4 the same thing as -6 plus 10? It is. Okay, so you're always invited to check that way. All right. All right, so let's go back to this one. And again, I have x's. It could be any letter. It could be w's or t's. They're just using a lot of x's here. And I have to ask myself, do I want x's on this side or this side? Can't have them on both. Where do you want to move them all to? All right, now, well, it feels a little unorthodox to put x's on the reverse side. It may be to our advantage to put it over here so that if I were to move the subtract 4x over to the other side, then that would save me a little bit of work. I wouldn't have to move this over and then this guy over if the opposite was considered, okay? So I'm gonna move all the x's to this side. And so I am gonna get rid of this guy and we'll put a number there instead, sign. I just want constants there. And so my 10 is my constant. I don't want the negative 4x there, the subtract 4x. I want all the x's on this side, okay? All on the right side. Okay, so the opposite of subtract 4x will be to add 4x. But whatever I do to one side, I'll do it to the other. These guys will go away. Your 10 comes down, and it's a positive 10. It's whatever sign is out in front of it, not the one that's behind it. Okay, so positive 10 is equal to, let's see, negative 9 plus 4 is negative 5. And if you're not sure about that, again, use a calculator. Negative 9 plus 4, just see what you get. Okay. All right, don't forget to bring the x down with it. And remember, there's a time sign there. Okay. And your last step is to get x by itself. And the opposite operation, the inverse operation from that negative 5 times is a negative 5 divided by, kind of like what we had over there. And by pure coincidence, the answers are the same. It's 10 divided by negative 5 is negative 2. That's just weird. Okay, it just happened to work out that way. Okay, but that's it. All right, so I'm hoping it's not too overwhelming in terms of what we did. It's just the idea that, yeah, you may have x's on each side, and you just got to move one set to the other side. Okay, a little bit of commitment there. All right, so this one's a little bit bigger, and the only thing that makes this bigger is that you do have to distribute. You can see you have a 2 with a set of parentheses here, meaning you're going to have to multiply 2 to both of those terms. And the same thing with this 0.5, okay? Remember, 0.5 in terms of a fraction is just the same as a half. Okay, so what I'll do is I'm going to get rid of these parentheses first. I can't commit to what side I want x to be yet. I have to get rid of parentheses, which means I'm going to distribute. Which means in the first part, I'm going to multiply 2 times each of these two numbers. So 2 times 3 is 6, x. Okay. Recopy the sign. And 2 times 4 is 8. All right, and then I'll do the same thing over here. I'm going to take 1/2, or 0.5, multiply it by 10, and multiply it by subtract x. Okay. Now, if this is confusing, remember you can always use a calculator, but if I take half of 10, that's the same as 1/2 times 10. And half of 10 is 5. Okay. And then half of an x is just 1/2 x. So you can write that as 0.5x, or you could write it as a half x, whatever makes it easier for you. And now at this point, like I did in the previous page, I have to commit to which side I want to have x on. Okay, so I have an x over here, and I have an x over here. Can't have them on both sides. Which way do you want to do it? And it's completely up to you. It will look a little different depending on the way you chose. However, the answer should be the same for both. I'm going to choose to put the x's over here just because I think it's more comfortable to have the x's on the left side when I can. Further, if that's the case, and I just put plain numbers over here, the nice thing is that my x's are going to be positive. Okay, so here's what's going to happen. I only want x's on this side, so I can't have this x over here. This guy has to go. All right, and so the opposite of subtract 0.5x is to add 0.5x. All right, and if I add 0.5x to one side, I have to do it to the next. Okay, and so that means that this guy comes straight down, and the subtract 8 will come down. And 6 plus a half is 6.5x. Okay. All right, let me stop for a minute. Or first, if you like, you can always pause it. All right, pause our video here. and just kind of take in what we did. And if something needs to be talked about again, you can rewind it, okay, and meet up with us back at this part again, okay. At this point, again, I have x's on this side, and now I have a question like 1.2. I have two-step equation, which means I have to get rid of the 6.5, and I got to get rid of the subtract 8, right? And again, remember, we typically do add and subtract first, okay? So if I see subtract 8 here, I'm going to do the reverse opposite operation, which is add 8. Okay, so those will go away. 6.5, and that's like times x. You don't have to write the times, but that's really what it is. And this gives me 13. Okay. And then remember, the final step is to multiply or divide. Okay, so there's really a time sign there. So the opposite operation of multiplying by 6.5 is to divide by 6.5. Okay, now some people are like, I don't do well with fractions and stuff, and that's fine. You can just use your calculator. Just take 13 divided by 6.5 in your calculator, and you'll find that you get 2. All right. A positive divided by a positive is another positive. Okay. All right, there we go. Hopefully that makes sense. If not, again, you can pause this and go backwards and rewatch that part over again just to make sure you got it. All right, this one's not much different other than you have a fraction here. You also have a different variable. You have the letter n. No big deal. We can handle that. The other thing that makes this a little bit different is you have a subtraction sign. And we don't distribute negatives very often. But remember, when you distribute a negative, what that's going to do to each of your products is to change the sign of the items that you have in the inside of your parentheses. So when you multiply 3/4 times 8, that negative times a positive is a negative. All right, now you can do 3/4 times 8 in your calculator if you like. Or if you don't want to, remember you put the 1 underneath the 8, and then you just multiply straight across. 3 times 8 is 24. I do not need a common denominator, so 4 times 1 is 4. And 24 divided by 4, if you do those in a calculator too, you get 6. Okay, so this is negative 6n. And 3/4 times 12, same idea. I'll put that up a little higher. 3/4 times 12. Now don't take 3 times 12 and then 4 times 12. Remember, 12 is really 12 over 1. So 3 times 12 is 36. And 4 times 1 is 4. And if you divide those out, again, you can use a calculator and get you 9. And remember, a negative times a positive is a negative, so you're going to put a subtraction sign there. Okay. I will tell you that the most common mistake in a big question like this is related to this guy right here. Okay. People are pretty good at multiplying the first guy through by a negative, but they always forget the second. This sign will always change when there's a negative out front. Okay, so be careful of that. Careful. Okay, now do the same thing here. 3 times n is 3n, and 3 times 3 is 9. And like before, I have to commit. I have to decide which side I want my x's on, or in this case, my n's. And if there's no real preference, I'm going to put it on the left side. And I'm just going to put the numbers over here. Those are called constants again. And so what that means is this thing has got to go. I cannot have a subtract 3 in there. All right, so I can't have a 3 there. So I'm going to subtract 3 in. And if I subtract 3 in here, I have to do it to the other side. There's my dotted line. And make sure you put it underneath the right item. Don't put it underneath the 9 because the 9 doesn't have an n with it. Okay. Put it underneath the 6. N. Okay, so those will go away. Negative 6 and a negative 3 together gives you a negative 9n minus 9 equals negative 9. Now I have a two-step equation like I had a couple days ago. Let's get rid of the subtract 9 that we have here. And to get rid of a subtract 9, we will add 9. And so these will go away, and the -9 times n will come down. And -9 plus 9, you can do that in your calculator if you don't know the answer, but that is 0. And that'll make the last part nice because we've already addressed this piece. Now we're going to do the multiplication division. This is a time sign here. I'm going to do the opposite of multiplication. So if I'm multiplying by -9, the opposite operation is to divide by -9. Okay, so those will go away, and you're left with n is equal to, now 0 divided by pretty much anything, okay, in this case -9, will give you 0. Okay, and at that point, we are done. If you would like to check it, all you would do is take 0 and put it into the equation. This is something that's kind of cool to do on your test because you can check to see if you got it right. Okay, and that's what it looks like before you put in 0. I'll just use a different color here. And I'll plug in 0 there and 0 there. And so this ends up giving you -3/4 still out front. And the part in parentheses, 8 times 0 is 0 plus 12 is 12. And then this gives you 3 times -3. And you'll find that if you do the math for both of these, and we've already done this part here, that's up in this location. That gives you -9. And so does this bottom, okay? Or this part right here. So those match up, and that means you did it right. All right, if that's hard, okay, again, you can go back, pause it, and look at it again if you like a maybe a little bit slower pace. And again, if you have any questions on it, just holler at me, okay, and I'll be happy to help you out. Okay, let me move myself a little bit here. You're like, dang, this feels like a lot. And it's really not that bad, okay? It's basically the same stuff. The only difference is that you have multiplication through the use of distributing off to the left here, okay? So let me just do this part real quick. 3 times 5 is 15x, and 3 times 2 is 6, equals 15x. And you're going to notice that a lot of these have something special in common, okay? And as we break this down and decide where x goes, maybe I'll say x goes on the other side. And over here, I'll put the number. Well, that would mean I have to subtract this 15x over. This has to go because I need all the x's on this side over here. However, when you do that, these go away as you would expect. But on the right side, 15x minus 15x is 0. And when you get 0 or 0x, you're kind of done because you don't have any x's left to work with. Okay. Now you have to ask yourself, is 6 equal to 0? And this is a fat no. Okay, not. Okay, and if you ever get your x's to go away completely, because sometimes that just weirdly happens, then what that means is you look at your statement at the end, and since this is false, okay, what you're going to say is that there is no solution. There is nothing that you can put in for x to make this to work. Okay, so the original to work. So no solution. If you want to say this, that's fine too. Let's do it again. -2 times 4y is -8y. Remember that this next piece is typically the most missed piece. -2 times 1, yeah, we're going to get a 2 there. But remember that this sign will change from addition to subtraction when you have this fancy negative out front, okay? And you are distributing that through. Okay. And then on the left side, or sorry, right side here, we got -8y minus 2. Now, you'll notice something kind of funny here. Like the other one, where these 15s matched up, here you got -8s that match up. Okay, so I can add 8y to both sides, and something similar happens. Your y's are going to all fall apart and go away, and the thing that will come down is a -2, and the thing that will come down here is also a -2. Okay, now something that's a little bit different is when these all collapsed out, we ended up something that was true. Okay, -2 is equal to -2, not like 6 equals 0. If you get a false statement, 6 is not equal to 0, okay, then yeah, you write no solution. If you get a true statement, okay, something different is going to be in your answer, okay? So if you get a true statement, you're going to write infinite solutions. Okay, that's a U. Infinite solutions. So that means there's a lot of numbers that will work here, okay? So we'll write that, and that's all you're going to say, okay? You are good. All right, next one. See if the same thing happens. 4 times 1 is 4. 4 times subtract p is minus 4p. And again, this gives you minus 4p plus 4. Again, same situation here. Let's get rid of the p's by adding a 4p to this side. Those are going to go away. But again, whatever you add to one side, you have to add to another. And those will go away. And so you end up with 4 is equal to 4. And is 4 equal to 4? Does that match either the first one or the second type? And it does match the second type because 4 is equal to 4. That is true. Okay, and so what you're going to say is infinite solutions. Okay. They may say this. They may say all real numbers, but I think what I have is right. Okay, so I think that's what they're going to have. All right, we are proceeding. You're noticing a pattern here. Things are canceling out. Okay, sometimes those are located next to each other in problem sets that we have. 3 times 2 is 6x, and 3 times 2 is 6. Okay. And vice versa, same thing. This is 6x minus 6. Okay. Like before, you notice that they're the same x terms on each side. They're both 6. Let's subtract those out. Okay. And you get -6 is equal to -6. Okay, and again, that matches the last two. -6 is equal to -6. Okay, and I'm going to write infinite solutions. Awesome. All right, last one. Okay, again, you notice that these all look like they have something in common. Let's decide this. Let's get all the k's, in this case, over here, and all the plain numbers on the right side. Okay, now you'll notice I have a 10k and actually a subtract 10k. So if I don't want the k's here, if this thing has to go, I'm going to write the opposite operation, which is to add 10k. Okay. And I wrote a big line here. Let me get rid of it. And so what we're going to do is add these up. 10 plus 10 is 20k plus 7 equals -3. And a lot of people look at that and say, wait a minute, all these other ones had the variables cancel out, like all the x's canceled here, all the y's, all the p's, all the x's canceled. This didn't happen here. And that's why I wrote this. It's a trap. Sometimes you feel like when you're doing all these problems that are the same, they throw one of these in here and you're like, well, doesn't this supposed to match all the other ones? Is this a typo? No, it's not. Okay, what it means is you have to treat this like a normal problem. So be careful. Don't always assume that because some of these are in a row that you can't throw just a regular traditional problem in with all these kind of more unique ones. Okay. All right, so we have all the k's on this side, and we got to get rid of this 7 here. So let us do the opposite operation. Instead of add 7, we'll subtract. Okay. And -3 and a -7, you can do that in your calculator if you want, but that gives you a -10. And be careful on your last step. Remember, we always try to do plus or minus first, add or subtract, and then the multiplication and division, okay, is always second. We've already done this piece, we have to divide. Divide by what's with the k, which in this case is 20. Okay, and we are set. So negative 10 over 20 does reduce, okay? And why is that important? Well, oftentimes when we do these math problems in your computer, and there's the clever responses that you have to put in, they may want a more reduced response, okay? If you're having even further trouble, remember, like, where am I at? Where's my cursor? Negative half is the same as negative 0.5. Sometimes you can try it like that. Fractions are always best though, okay, because they're complete, all right? Sometimes people round fraction or decimals, and that's where they're off just a little bit sometimes. Okay, I'll be the first to say I know you all hate word problems, right? You're like, no, I'm just gonna skip these. I'm gonna move myself to the other side so I'm out of everybody's way. However, I'm going to try to make these as simple as possible, okay? And the way you make these most simple is by staying organized, all right? And so your work for this class will involve the formula that we learned last week. Rate times time equals distance. Okay? Remember that rate is a speed. Okay? Time, we know what that is, okay? And then D stands for distance. I sometimes like to draw a picture, all right? So here's what we got. We got a boat that's traveling upstream on the Mississippi for 4 hours. Okay, so here's my starting point. There's my wave. Here's my boats. Let me say this is a pretty good drawing for my pencil here. And I'm going for 4 hours. Okay. It says after 4 hours, the return trip takes only 2.5 hours. Okay, so that was going this direction, but we eventually stopped. The return trip was a little bit faster. Okay, so I have to go back to where I started, but again, I'll stop. And this took 2.8 hours. Okay. All right, and here's what it said. Why did it take 2.8 hours? It says because the boat travels 3.5 miles faster, miles per hour faster downstream due to the currents. Okay, so I don't know what this speed is, but I know this one's 3 miles per hour faster. Okay, so based off this, I'm going to make a little chart. I'm going to talk about going upstream, and then I'm going to talk about going downstream. All right, now, formula goes like this. Rate times time equals distance. Okay, so here's my rate. Here's my time equals distance. And notice how I'm spacing it out. Okay, so here's what I know. I know the time for the first guy was 4. Okay, so I'm going to put that in. This guy was 4. And the other guy was 2.8. Okay. Let me write that in, 2.8. Okay, now I don't know how fast either one was going. Okay, I just don't. They don't tell you how fast it's going. So I'm just going to call this first guy R, because I have no clue. Okay. Further, okay, going downstream was faster. And the only thing I know is that whatever this guy was here above, this one is a little bit faster. He's 3 miles per hour faster. So if this guy's 3 miles per hour faster, then what I'm going to do is just call this R plus 3. And that's the hardest part. Can you write these two guys in? Okay. One is typically just a plain R, and the other one's going to be R plus or minus, depending on what we're talking about, whatever they tell us. Okay. And if you can figure that part out, the rest is pretty easy. Okay. Now you're like, what the heck am I going to do with this? Well, in the end, they want to know what is the distance. Okay. Well, I don't have to know what the distances are. I just know that they're the same. The amount of distance that I traveled the way up is the same as what we traveled back, because this is upstream. This person eventually stopped, turned around, and then went downstream, and then returned to the original location. Okay, so the distances are the same. Okay, and here's the idea. If the distances are the same, then so are these guys. Okay, and that's what I'm going to do. I'm going to take these parts out front, and I'm going to set them equal to each other. Okay, so the first one says r times 4. Let's make that look a little nicer, because I don't like r times 4. Let's call that 4r. Okay, and this 4r is the same as what I have right here. These are both equal to d, and that means they're both equal to each other. Okay, now this says r plus 3 times 2.8, and I'm going to just flip it around. If it doesn't make sense while I'm setting these, why I'm setting these equal to each other, imagine this. If I said 1 plus 2 is equal to 3, would you agree with that? Sure you would. Okay. If I said 6 minus 3 is equal to 3, would you agree with that? Sure you would. Now, if these are both equal to 3, is it okay that I set them equal to each other? Does it give me a true statement? Sorry. Okay, does it give me a true statement? Do these front pieces equal each other? And you can see that, yeah, 1 plus 2 is 3, and 6 minus 3 is also 3. Same idea. These are both equal to the same distance. I know that the length distance going up for 4 hours was the same as the distance going back for 2.8 hours, okay? Because whatever you're doing upstream, they had to turn around and come back to the same dock going downstream, okay? So that's why we set these two equal to each other, okay? But again, I cleaned it up. I put the 4 out front of the r. I put the 2.8 out in front of the r plus 3, and I'm going to distribute. Okay, now 2.8 times 3, if you're like, I don't know how to do that, no sweat. You can do it off to the side or put it in your calculator. 3 times 2 is 6, 8, so 8.4. And you have to decide, how am I going to make this look a little bit better? Okay, how am I going to simplify it? Let's put the r's on this side, and let's put the numbers on this side. And so let us subtract, sorry, I forgot the r here. Okay, I forgot the r. Let's subtract a 2.8r. Okay, and so that way these guys go away. Okay. And let's think about this. 4 minus 2.8. You can do it in a calculator, sure, but I'm going to do it off to the side here. 4 minus 2.8. That would mean that I have to make this a 0 here. And by borrowing and making this a 10, this becomes a 3. I get positive, because 3 minus 2 is 1. And 10 minus 8 is 2. You get a positive 1.2. And some of you may have been able to do that in your head. That's awesome if you did. Okay. Again, like all our other problems, we always add and subtract first, like we did right here. And now we got to do some multiplication or division. And it's kind of the same as all the other ones. The item that's being multiplied by the r is 1.2. So the opposite of multiplication is divide. Okay. And that may be tough for some. If you want, you can kind of look at it like this. It's 84 divided by 12. And that's, if you did it in your calculator, gives you 7. Okay, now, that's a lot of work. Okay, that includes a drawing, some setup for an equation here, okay? Some interpretation, just knowing that these front pieces are equal to each other because the distances are the same, okay? And I'm hoping that this kind of helped reference why that was okay. Okay, a little distributing and then solving, R is 7. Now, that's the rates of the boat going upstream. Sorry, not 8, 7. Okay, and if I'm going downstream, well, the downstream was the same rate as what you had here, plus 3. So the rate downstream is 7 plus 3, which is 10. Okay. Now, which one does it ask for? How far does the boat travel upstream? Well, if this was 7 and the time was 4 hours, 7 times 4 is 28. So total distance, okay, is 28. 7 times 4 is 28 miles. There you go. All right. So, hey, this was important. Remember that some of our work is put into a computer, okay? So a lot of times you'll do all this math perfect, okay? But maybe not answer the question correctly. If I say far, that is a D for distance, okay? You just got to finish that last piece by just using your formula here, okay? 7 here, 4 here, 7 times 4 is your distance, 28. Bad. All right. Here's what I want you to do. I want you to hit the pause button, and I want you to try this next one on your own, knowing, before you do this, that again, rate times time equals distance, and you're going to have another upstream, and you have a downstream. Okay, I know it's sloppy, sorry, it's the bottom of my tablet here, and it's hard to write with. And here's what I got rate times time equals distance. Okay, and some people like to make it chart-like. They like to do something like this. But it's up to you. Okay, and again, this is an equal to, that's an equal to, but it reads very closely to what you had before. Okay, so hit pause, give it a try, and then we will work the rest of this out together. See if you can plug in these things into like these 4 boxes like I did here. And I'll put this in yellow so you can see it real quick. Actually, I'll make this gold. Okay, see if you can do just the rates and the times for each. If you can do that, you're great. Okay, pause and take 30 seconds, okay? And I'll do the same. Okay, so here's what mine looks like, okay? Again, it reads the same way. You're going upstream at 3.5 hours. The return trip takes 2.5 hours. So I wrote upstream and downstream. Here's my 3.5. Here's my 2.5 below that. And it says that going downstream takes 2 miles per hour faster than upstream, okay? So whatever the upstream was, this is 2 faster, okay? Okay, so here's what we're going to do. It says, how far does the boat travel upstream? Okay, same type of question. And here's what I got. Remember, we take these things, right? And we just set them equal to each other. And maybe I'll do it kind of in a clean way first. This is really R times 3.5, but I really want 3.5 R, okay? And the same thing here, 2.5 times R plus 2. Let's write that kind of nice to begin with. Don't forget your parentheses. That's a huge deal, all right? And I got to distribute. Okay, so 2.5 times R is 2.5 R. And 2.5 times 2, you can use a calculator, but think about this. 2.5 is like 250. You have $2.50 and you double it. What do you got? Yeah, $5. Okay, so plus 5. All right, now here's my little line, and I get to get all the R's over here. And how am I going to do that? I'm going to get rid of the R's on the right side. Okay, and 2.5 from 3.5 gives me 1. Okay, so it's just 1 R. You put a 1 there if you want. And all I got here is 5. And the cool thing about this is, I mean, you can divide by the 1 if you want, but R is 5 is my answer. Okay, now it's just the first half. okay? Because it says how far does the boat travel? Well, R is here. Remember, rate times time equals distance. Rate is 5. Your time for that was 3.5. Okay, so as you look at this, rate was 5, time is 3.5. Okay, and the distance is what they're looking for. Okay, and again, sometimes people do all this math and they'll say, hey, what's the distance? And people type in 5, and that's not the right answer, even though it shows you really know what you're doing. You're just not answering the question correctly. Distance is the rate times the time. So make sure you read it correctly. 5 times 3.5, if you're not sure what that is, then put your graphing calculator, and I think you get 17.5. Let me check it out. 5 times 3.5. Yeah, 17.5. So that's how far you traveled, either upstream or downstream. It'll be the same either way. Okay? All right, that's all I got for you. Here's what I need, okay? Just to remind you again, I know I've talked about it a couple times. This item here is your notes. Just hang on to it, okay? Once you do this assignment, okay, in Clever, don't forget to hit submit. That's important because some people are spending a good amount of time, very sincere amount of time doing their work. They're not hitting submit at the very end, and it's not calculating the questions and seeing what you're getting right. Second, sometimes questions like this will have 2 parts to it. And as I'm looking at some of your answers, you're answering a lot of them correctly, but you're not doing both pieces. There's like this part A and a part B, and you're just doing part B and you're not noticing part A. So I can see your answers, and sometimes people are getting stuff wrong because you're leaving a blank, and I don't think you're realizing it. So, so look for all the questions within a single problem. Sometimes there's 2 parts to it, okay? And again, the part that you upload for the assignment in Google Classroom are the scratch work that you do when you're doing your homework, okay? Don't upload your notes just yet, okay? It's the scratch work to your homework, okay? All right, and make sure it's nice and clean, just like your notes are, and very complete, just like we did our work here and all the ones above it, okay? All right, thank you so much. Hope you have a great day. If you have any questions, send me an email, and we'll chat about it, okay? All right, we'll talk to you soon.